Really quick on this problem right here that we just corrected. You're going to need to know this for the test, so please make sure you're aware of this. There were a lot of 4s there. I assume most people just missed getting 30 or 46 correct. So here's the test. The test for odd or even is you plug in a negative wherever there's an x. So this is going to be negative x squared minus 1. So this is going to be negative x on the top, and the bottom is negative x squared is going to be x squared minus 1. And then we compare this to the original one. So the first question is it the exact same? Nope. So there's no way it can be even. So we can be guaranteed that it's not even. Okay, but now we want to check, is it the exact opposite? And how do you tell whether a fraction is the exact opposite? Okay, either the top or the bottom is the exact opposite, not both. So the bottom is the exact same, and the top is the exact opposite. Okay, the example I gave the other day is if this were 3/4, the opposite of 3/4 would be negative 3/4. And notice there's just a negative in front of each one, and that's what happened here. Okay, so that's why that one's odd. Okay, so make sure you're aware of that. Okay, so let's take a look at 3.4. What goes in the blank here? Anybody know? Every function makes a shape when you graph it. It's called a transformation. Okay, that word right there. So when we transform a graph, that's the name right there. It's called a transformation. And the cool thing is, if you learned those transformations really well with parabolas in 1010, this is going to be pretty darn easy. We're going to be able to use the same ideas that transformed parabolas to transform any shape. So all of those parent graphs that we learned yesterday, that you worked on in 3.3, okay, same thing here. So here's our squared graph. So again, that goes through 0, 0, 1, 1, and 2, 4. It's symmetric, it's an even function. So we've got 2, 4. I'll label these 1, 1, 0, 0. This one's negative 1, 1, and negative 2, 4. Okay, and if you were in my 1010 class, and probably even if you were in Mr. Price's 1010 class, you probably talked about this the same way. This is the parent graph of the parabola. The vertex is at the origin. It's at 0, 0. Okay, and this pattern of how we make the shape is really important. So this is like the central point. Okay, from the vertex, we normally go over 1 and up 1 squared. We go over 2 and up 2 squared, over 3 and up 3 squared. That's why we go over 1 and up 1, over 2 and up 4, over 3 and up 9. And it doesn't matter whether we go to the right or the left, because when we square, you go back 1, up 1 squared. Okay, up because squaring would make it positive. Back 2, up 2 squared, that would be 4 there. Okay, and we've got that axis of symmetry and all that sort of stuff. So, what does the plus 1 do to the graph? All it does is move it up 1. So if you know where it moved the vertex, from there we can go over 1, up 1 squared, over 2, up 2 squared, and you can figure out where those points were moved. So this new graph looks like this. The old one looked like this. All we did is we took every single point on the old graph and just moved it up 1 unit, exactly 1 unit for each one of these points. Okay, that's all. What does the minus 3 do? Move it down 3. So that would put the vertex here at 0, negative 3. And where would this point right here be? One comma, up 1 from negative 3, so that'd be negative 2. And the other point would be over 2 and up 4, so that would put us right here. If we go up 4 from negative 3, that would put us at 2, 1. Okay? That's enough for me for right now, but that's what it would look like. Okay? And the point here is, okay, everybody watch please. Okay, this is a little bit different than what you would have seen in 1010, because in 1010 we dealt with one graph specifically, x squared. Okay? This says any graph, if you know the shape of the original function, so we went through a whole bunch of functions yesterday. If you know the shape of the original function, if you make that shape and then add k, you move the graph up k units. If you make that shape and then subtract k, you're going to move it down k units. Make that look right. Okay, and we call this a what type of shift? Vertical shift. Okay, so this is a vertical shift. Okay, now what I want you to take note of is that is completely different than what goes on here. Okay, everybody watch please. Okay, if you didn't get this in 1010, make sure you have it now because these shapes are going to be a little more complicated than the ones that you did in 1010. So here we make that shape and then we add or subtract something. That takes the graph and just slides it up or slides it down. This is fundamentally different what's going on with these guys right here. The very first change that you make is when you plug in a number, the first thing you do is you add something to it, then you square. Remember, squaring makes that parabola shape. So we're changing the x, so it's going to move it in the x direction. But what's the weird thing about these changes? Okay, they do the opposite of what you'd think. So this is going to move it to the left 1 unit. So we're going to slide the vertex over here. And then we still go to the right 1, up 1, to the right 2, up 4. So it still looks like that. It still looks exactly the same. So the vertex would be -1, 0. This point would be 0, 1. This point would be 1, 4. It's the same exact shape as the original one. It's just that it got moved. All those points got moved 1 unit to the left. Okay. What does this one do? 3 units to the right. So 1, 2, 3. That's where the vertex is. That's the only change we made. So over 1, up 1. Over 2, up 4. So it looks something like this. You should be able to label 5 points on these graphs. 3, 0, 4, 1, 5, 4. This one would be, well, let's see, that's 2, 1, and this one is 1, 4. Okay, any questions? Okay, so again, notice what we've got going on here. Here's the function that makes the shape. This is the function that we know, whether it's a line, a parabola, a cubic function, a square root function, okay, any of those. If you know what the shape is, if you plug in x and then the very first thing you do with it is you add h or subtract h, if you add something, we move the pattern which way? Left. If we subtract something, we move it right. Okay? Now this blank right here is going to have some type of shift. What type of shift is that? That is a horizontal shift. Okay? Okay, 2 things. Everybody watch. Okay, just watch up here. See this point right here? That point is on the graph. If I were making this up, it wouldn't work in the equation, but watch what happens. Here's my x and here's my y. So y is 4. 4 should equal the x, which is 5, minus 3 quantity squared. Is that true? Yes. It is. Okay? So I can graph the entire thing. I can get a picture of all the points that work in that ugly equation right there just by knowing what those transformations are. Okay, that's one thing. The next thing is, can somebody remind us and tell us why this one moves it 1 unit to the left and this one moves it 1 unit or 3 units to the right, when it seems like it ought to be the other way? I mean, if you add, you'd think it would move to the right. If you subtract, you'd think it would move to the left. Shane?
Because it actually makes it sooner.
Okay.
X plus 1 becomes 1 unit sooner.
Okay. It makes the shape 1 unit sooner than it normally does. And subtracting 3, it makes the shape 3 units later than it normally does. Because remember, it normally makes the shape like this. Okay? That kind of slows it down. It makes it 3 units later. Everybody good there? Okay, flip it over. Okay, those are the really basic ones. Now we're going to remind ourselves of the ones that, this makes the points a little harder to calculate depending on what they are. But if I multiply this by a negative, so if I know the shape and I just multiply the shape by a negative, what does that do? Okay, flips it across the x-axis, it flips it vertically, right? So it normally looks like this. Now it looks like this. It doesn't change where the vertex is, but it does change the fact that we go to the right, and now we go down 1, go to the right 2, down 4. So again, we've got that nice symmetry here. So the vertex would still be 0, 0. This point right here would be 1, -1, and this point right here would be 2, -4. Of course, we've got those other symmetric points, so this would be -2, -4, and -1, -1. Okay? Any questions there? Okay, what does the 2 do to the graph? Okay, elongates it is a pretty good word. Can somebody else describe it differently? Makes it taller, makes the points taller, makes the points twice as tall as they used to be, stretches them vertically, right? Okay, so if we take a function, if we know whatever the shape is, and we multiply it by a number, it's going to be a vertical stretch or a vertical shrink. Okay, it's going to shrink it, okay, shrink it or stretch it. Okay, so this one is going to stretch it. So the original points were, let me make this a little bit larger so we can see them. Here's where the original one is. That's what the original one looks like. And now we're going to graph the other one. Now remember, this point right here is 2, 4, right? Okay, that's still 0, 0. We haven't slid it left, right, up, down, or anything like that. We're going to go over and up 1. We normally go up 1, but the 2 makes us go twice as far. So this is going to vertically stretch it by a factor of 2, so that's going to be 1, 2. We normally go over 2 and up 4. We're going to go over 2 and up 8. So that's where this is going to end up. So it looks like this. Okay, now what it did is it made the graph steeper. It made all the points taller. It did not do this. Everybody watch, please. Okay, it didn't do this. Okay, everybody looks at this and they say, oh, it made it more narrow. It made it skinnier. It didn't do this. What it did is it took the graph and it moved the points up, vertically stretched it. There's a big difference there. It's not a huge difference. It doesn't look that much different. It doesn't look like a big deal when you're dealing with parabolas, but it does when you're dealing with other functions. Okay, so be careful with that. All right, and the 1/4, it does this, shrinks it. Okay, it doesn't do this. It doesn't make it look. It doesn't go like this. It's not horizontally stretching it out. It's not making it fatter. It's making it shorter. So again, normally we go through 0, 0, 1, and then this would be 4. Okay, this is going to make all of those points 1/4 as tall as they normally are. So, haven't moved it anywhere. All we've done is change the shape a bit. Instead of going over 1 and up 1, we're going to go over 1 and up 1/4 as far as we normally do. So that would be 1, 1/4. Instead of going over 2 and up 4, what's 1/4 of 4? 1. So we're only going to go up to 1. So that would be 2, 1. Okay? So there are 3 points on that side. We've got those symmetric ones on the other side. So this graph looks something like this. I realize it looks wider, but that's not the best way to think of it. Okay? So it looks something like that. Any questions? Okay. So if that number is a number bigger than 1, it vertically stretches it. If it's a number between 0 and 1, it shrinks it. What if it were, say, like this, a -2? Flips it upside down and vertically stretches it. Okay? All right. Let's see. So what's that one going to do to the graph? Up 2. What's that one going to do? Down 1. That one? Okay. 3 times taller. Okay, we could call that a vertical stretch, right? And we already talked about this. You can kind of treat these as 2 separate things. That is a vertical flip, okay? Seems weird, but it's across the x-axis, okay? And that is a vertical stretch, okay? All right. Any questions? Okay. Would you, on that graph paper that I gave you, would you draw this and label 5 points on it? Draw this one and label 5 points on it. Hopefully everybody's got 0, 0, and it opens down. So we'd go to the right, and then we're going to go down. We're going to go down 2. So that would be 1 comma negative 2. We're going to go over 2, and we're going to go down 8. So this is going to be 2 comma negative 8. And then the nice thing about the symmetric points over here is you can graph them really quickly, and the y coordinates are exactly the same, because remember, this is an even function, and we just have to figure, well, I went back 1 and I went back 2, so that's what the graph would look like. Okay, and as long as that's labeled, anybody looking at that, you labeled everything, they'd be convinced you know what you're doing. Okay, any questions there? Okay, all right, let's take a look at these guys right here. What does this do? Right 3. What does that do? Left 4. Okay, now what I want you to notice is this. X squared is all by itself. X squared, then we add 2. X squared, then we subtract 1. X squared, then we times it by 3. X squared, then we times it by negative 2. All of these are done after the squaring, after it makes the shape. So we make the shape and then we do something to it. We slide it up or down, we stretch it or shrink it. Okay? All of these are vertical change if you change it after it makes the shape. Okay, look what happens here. The first thing I do again is I subtract 3. That's a horizontal change. I add 4, then I square, so that's a horizontal change. So anything inside the parentheses, okay, any way you change the function before it operates and makes the shape, that's going to be a horizontal change. Okay, anything after that is going to be a vertical change. So if we put all of these together, what does that one do? The 2. 2 times steeper. Okay, it's a vertical stretch. That's going to be left 1, and that's going to be down 4. Can you graph that? Go ahead and graph that on the other piece of paper. So 2x plus 1 quantity squared minus 4. So again, we're going to take our shape and we're going to do what with it? Move it back 1 and down 4. That's our vertex. So negative 1, negative 4 is our vertex. And then we're going to go to the right one and we're going to go up 2 from where we were. Same thing on both sides. To the right 2, and we're normally going to go up 4. We're going to go up 8. Okay, everybody watch up here. Let's make sure you got it right. Vertex is at negative 1, negative 4, because that moved us to the left 1 and down 4. There's our vertex. And then we're going to go over 1 and up twice as far as we normally do. So that point right there would be 0, because we went to the right 1. Up 2 from negative 4 would be negative 2. If I go over 2, this is going to put me at 1 comma, and if I go up 8 from negative 4, that puts me at 4. Is that right? Okay, what's the y coordinate for this guy over here? Should be 4. What's the y-coordinate for this guy right here? Should be -2. And all I have to do is figure out, I was at -1, I went back 1, so that'd be -2. I was at -1 and I went back 2, so that would be -3. Those should be the 5 points. If you were asked to graph all 5 of them, that's what you should do. Okay, any questions there? Okay, this is the last one, and then we'll get to some other funky problems. Okay, what does this do to the graph? The -1/2. Okay, it vertically flips it and makes it half as steep. Okay, shrinks the points. Okay, what does the 3 do? Left, and this one up. So this is going to be back 3 and up 2. So there's my vertex, -3, 2. And then I would normally go over 1 and down 1. I'm going to go over 1 and down 1/2. I would normally go over 2 and down 4. I'm going to go over 2 and down 1/2 of 4, so that's going to be down 2, so that's going to put me right here. So this is enough that I can graph it. I've got the 5 points here, and I've got my shape. A little less steep than it used to be, and then the big question is, can you label all 5 of those points? Hopefully this one isn't too bad. Everybody watch, please. This one right here. If I was at -3, 2, and I went over 2, that would put me at -1. But if I go down 2, that puts me at 0. Okay, which means I know the y-coordinate for this one right here. If I was at 3 and I go back 2, that puts me at -5. Now the tough part is that point right there and the one next to it. Okay, the x-coordinate should be pretty easy. How far did I go to the right? Just 1 unit, so that's going to be -2. And I went down 1/2. If I'm at 2 and I go down 1/2, where does that put me? 1/2, or we'd normally, instead of writing 1/2, we normally write 3/2. So this would be 3/2, which means I know this y-coordinate over here, that's 3/2. And the x-coordinate, look at this nice symmetry, -5, -4, -3, -2, -1. John?
If we wrote 1 and 1/2.
Yeah, that'd be fine. Okay, I wouldn't, string you up for it or anything. All right, any questions? Okay, back to this page right here. Okay, your homework assignment is at the bottom of this. We're going to take part of Monday to finish this up. I do want to show you a couple quick things though. Okay, these are changes you would not be familiar with because they were not shown to you in 1010. Okay, this is a 1050 type thing. So if we took this right here, now keep in mind what we were talking about up above. Okay, if you change the function after it makes the shape, that's a vertical change. If the first thing you do is you start monkeying with the x, you start changing the x in some way, multiplying it, dividing it, whatever it happens to be, that's going to change it in the x direction, in the horizontal change. So let's think about this right here. Plug in an x. What's the first thing that happens to it? It gets multiplied by a negative. Then we take the square root. So we know what this graph looks like, or we should. It's the top half of a sideways parabola, right? What would the negative do to that graph? Okay, if it normally looks like this, and this is what type of flip would this be? Careful. It's inside with the x, so that's going to be a horizontal flip. Horizontal flip. If I take this and I flip it horizontally, where does it end up? Over here. It's the same shape, just on the other side. Does that make sense? Okay. If you tried to plug in a positive, say we tried to plug in 4. First thing that happens to it is we multiply it by a negative, so then we try and take the square root of -4, and we know that doesn't produce a real number. Okay? So the domain for the original function was all positives, including 0. Okay? For this one, it's all negatives, including 0. Because if you plug in a -4, what's the first thing that happens to it? Negative times a negative is positive, then you can take the square root. So there is a point of 4, 2 on that graph. All right? Any questions there? Okay, so if we plug in a negative x, if we multiply the x by the negative, okay, the graph is horizontally flipped. Okay? So if it's horizontally flipped, what axis does it get flipped across? It's across the y-axis. Okay, that's a little counterintuitive. That doesn't quite make sense. Okay? Notice again, that's a horizontal change. Okay? All right. You might want to think about what the 2 would do to this and what the 1/4 would do. Okay? It is different than what the graphs, than what happened up above when we did those. So that's enough. You could get started on 3.4. You could at least look at it. Make sure you're done with 3.3 because we're going to correct that on Monday. Okay, thanks.